Hello everyone, I'm back in the shop today, and before I take this off the bench to start on some other stuff, I've already got some capacitors ordered for this radio, but I really wanted to get back in to find out why this S meter does not work on receive. As we saw in the last video, it works on transmit, but in receive it's completely dead. And when I powered the radio back up, I noticed that the second digit has that 9 back in there. So cleaning that band switch did not take care of that problem. Probably just a fluke that it had started working. So I'm thinking that the longer it stays on, the more it clears up. So it tell me it's probably either a bad connection in the counter, or one of them 74 series logic chips is going bad. So, you know, some driver chips in here, a bunch of 74 series that probably got to go down and replace one or two of them and check some solder joints on this counter. I haven't pulled this out yet and had a look at it, so yeah, I think that problem is going to be in the counter itself. Seems like, you know, it just don't seem to be the band switch. But I was doing some checking on the internet, and someone had left a comment showing another site where some guys had was showing some different schematics and some write-ups on the SB36. And the last time I did check, I had checked from the older computer in my house, and it was all in Japanese. But when I checked it out here in the shop and went back to that link, I mean, I noticed the link as soon as this person had posted it. I was able to hit the translate button, and it translated back to English. And I was going through that, and I got that schematic, and that schematic was actually revision 3. This is the original schematic that I have here, that came, you know, with the original book. And what I found out that this schematic is revision 1. So that tells you there was several more revisions in this radio. Like I say, this radio, you know, is SBE sideband engineering, but they also had a brand out called the Robin, and it was the 500A. But there's actually 3 different branded radios on this. In fact, one of the brands is on the back, and it is called Linear Systems Incorporated. So each one of these radios seems to be a different flavor. You know, they were all hand built, probably one at a time in somebody's shop that they had, and when they built these. And these originally was owned by Rayathon. So yeah, a lot of history, not a lot of stuff on the internet. But by finding that other schematic, I was able to look at a few things and figure out a few more bits and pieces of the circuit. So looking here at the revision 3 schematic, we can see on SM2 from the meter that there is a silicon, well, it's not a silicon diode, it's a glass diode, and it's an SD34, which is 1N34. We have already checked this 3K pot, and I could find no problems with it. It's close to 2.8, 2.9, somewhere in there like that. But one of the biggest things that I have to be concerned about is this capacitor and that germanium diode that's sitting in there. That may be the problem. I've already checked the transistors, and I went ahead and checked the electrolytic capacitors in this circuit. And, you know, I said before in the other video that we need to change out those electrolytic capacitors, because they're always failing, especially as old as this is. In this case, the electrolytics in here seem to be okay. They will get replaced though, but, you know, just checking in the meter circuit, everything I can find in the meter circuit, no problems at all. So as we look at the board, right here is that germanium diode, and you can see there's a control right beside it. So I wanted to look at the voltage on this diode and see if it makes any difference whatsoever. So I'm going to go ahead and connect the scope at that. We'll look at the scope, inject the signal, and see if there's any activity there. We should see a high and a low, depending on, you know, the signal strength. So I got my scope probe hooked up, and we'll go ahead and look at the scope and see just where that thing is sitting at. Okay, we're looking at the oscilloscope, and I've got it set for about 2 divisions, 2 volts per division. And when we inject the signal into the radio, you can see it drops down nearly to ground. But when we rotate the control, I'll inject the signal into it again, and we rotate the control, nothing is happening. So, you know, it kind of says, well, the control is bad, but like I said, we've already checked the control, and it does not seem to be the problem. So, again, the only thing in between that is that germanium diode. Okay, I went ahead and pulled that old diode out, and look what I found. The lead came completely out of the top of it. So I guess it was already cracked, and when I desoldered it, it just fell apart. So I'll get a new 1N34 and get that in, and we'll see how that affects the radio. Okay, as you can see right here, our new 1N34 is installed, and now I'm letting the radio warm up, and we'll give it a test and see how it does. Okay, I'll inject this signal into it. And look at there, our meter's now working. Isn't that cool? Okay, I got the generator set for minus 73 dBm, and let's see if we can adjust this meter to S9. Just a little bit more. Too much. I tell you what, it's very touchy. There it goes. Alright, we're right on S9. Okay, our S meter is now working like it's supposed to. And I thought that was very interesting that we were able to go in and just find a bad diode. But you know, that shows how much it helps when you have the correct service information. Now, looking at that schematic, it did match the IF RF board, but it doesn't match the oscillator in the final section. So I don't know what the folks over there at SBE was thinking when they built this thing, but yeah, it looks like you got to have several different versions of the schematic to work on the whole complete radio. And this kind of shows you that each radio was a bit custom built. There was no standard when they were building these things. You know, I also noticed that our 4 is back to a 4. There's no 9 in there. And it was like this when I first powered it back on after changing out that diode. So maybe that's just a bad connection or something going on inside the counter. I don't know if a bad logic chip would cause that state, not unless it heats up and cools down and something's changing. I don't know, but next time it does that, I'm gonna get this thing popped open and take a look at it and see just what's going on. I went ahead and opened up the display case, so you can just get a peek in there, and we can see this circuit board. Now I can tell you this thing puts out a lot of heat over here, and you can tell that just by the way these capacitors over here look. If I zoom on in, you can see that the plastic wrap around those electrolytics has shrunk up pretty good. So yeah, a lot of heat on this thing. But one thing that really concerns me was on the top side. You know, this thing has a vented cover on it, and just the amount of dust that has built up on this thing over time. So all that needs to be cleaned off. Get all that dust out of there. You know, logic circuits and dust does not go well together. And inside here you can see just all these logic chips that's used inside this unit, and they're really interesting looking. Each one of them has this little tag glued to the top of it. Now, like I say, I know these are 74 series, but they went back and just glued little tags on top of each one of them. So I thought, you know, I found that kind of interesting. And you know, looking at the schematic, we can see each tube here from V1 all the way up to V6, and it looks like V5 is the one that's causing the problem, and that one is labeled FE505G. So if we look at the radio, we can see this one here is labeled FE505G. So maybe that's the one that's causing the problems. But I'm going to have to tear this whole unit completely apart and, you know, desolder a lot of wiring, get this board out so we can either replace this or look at the solder joints on the other side. I'm pretty sure that a lot of these joints will need to be reflowed and touched up just from the age of this, but there's no need of doing any of that until I get all these electrolytics in here replaced. So as soon as those caps come in, I'll go ahead and start doing that. But anyway, I just want to give you a little tour inside this thing. It's really interesting the way that it's built. And you can see our little Nixies up here in the front running across there. Pretty little things. Well, I cleaned the board and put it back together for right now, so until we get the caps, you know, if we can get in there and start replacing stuff. Haven't noticed the 9 pop back up in the display, but it's holding good right now. But yeah, we'll tackle that in a much later video. we still got lots of other works, but you know, we're making headway. We now have a working S meter in this rig, and you know, we thought that was going to be a problem, but you know, just a simple little geranium diode that was cracked, and that took care of that problem. So now we can adjust our S meter and get that working like it's supposed to. Next step is, since just about all the functions of this rig is working, to get the stuff tore down, cleaned out, start replacing caps, get all that back together, check resistors, and then look at doing alignment and figuring that part out and getting everything on frequency like it's supposed to. Then I think we're going to have a pretty decent radio here. I'm pretty sure that the owner will be very happy with it. Now, again, you know, this technology is it's really something the way it's built. As we know before, SBE made a lot of scanners, CB radios. Again, these were originally built by Rayathon, but it'll be interesting just to see how well this radio performs. From what I have read on the internet, what little bit of information in there, they weren't perfect. There was issues here and there, and that's probably why so many of them was built different, you know, trying to resolve issue problems. Now the other one it's going to require a lot of work, but you know, it's a challenge that I don't mind taking on and trying to do, because I like to see stuff like this back up and working. A lot of people will get old radios like this, and the first thing they want to do is start snatching parts out of it and using it for something else. Old electronics deserve to live, especially when it's, you know, part of history like this SBE SB-36 is. So to me, I want to see them working, and working as intended, or at least to what the factory specs recommend on them. So, you know, I just hate seeing radios like this screwdrivered and took apart and sold off. You know, let them live. They deserve it. So there will be one other problem we'll have to look at when we go to deeper into this radio. As you can see in here, there's a lot of coil formers, and when we get down here to this one, you can see it wiggles. Now let me zoom in on that one just a little bit. Yep, you can see it wiggles, and that is because the former is broken, and all this is a clear tube with a rubber band down it, so that the insert can thread in and out. I'm looking at the coil around the former, and it's a little bit deformed, and probably what it is, someone stuck something like a metal screwdriver in there and jammed it in there and went to turn it. Well, if you can look in there closely, you can see that bit of glue that's on that coil and the slug inside, and that just locks that in place so it doesn't turn. And it's, I don't know, maybe wax, but yeah, someone just jammed a screwdriver in there and probably tried to tune that coil and crack this former in two. So we're going to have to go in here and desolder this coil and pull it out and dismantle it, take it apart, see if we can either find another replacement tube or glue this tube back together. Now I have repaired these type of tubes, and as long as all of it's still there, we can glue it back together. If not, we'll have to find another former to put in there. I mean, you know, going out and finding another identical coil just like that, it's going to be a bit impossible. But you know, we can probably fix that one. I got all the confidence in the world that we can. I don't see any problems at all. And for you guys that didn't know, if you notice the last digit, the 100 hertz, it does a lot of flashing, because these radios are going to drift quite a bit. So if you're trying to set this thing directly on like 14.200, you're going to notice that last digit flickers. And when they built this radio, they did come up with something to stop that, and right underneath the VFO dial is a button that you push, and when you push it, you see it turns that digit off, and it's so that you don't have to sit there and watch that thing flash all the time. Yeah, it'd been nice if it was just a 0 or 1 or 2 or 3 or whatever you put it on, you know. It's just not going to happen in these older radios, and they knew that when they built that, and that's why they put this little switch in. So you'll see it flash away. And if you go ahead and try to stabilize it, it's gonna start right back anyway. So you know, just no way around that. Anyway, I hope that someone finds this series of videos useful on what we're doing to this old SBE 36, and we'll keep working on it until we finally get it right. I'll get this video edited and put up here shortly, and I'll also get it over on my Patreon page. As you didn't know it, you can follow the link down below. We do have a Patreon page. I do not charge anyone for watching the videos on Patreon. They're all free, just like the videos here on YouTube, but I do post them on Patreon. I got some people that just follow me on Patreon, so if you like to go over there and look around, hopefully we'll get more and more users and more participation going on Patreon. We'll just see how that goes down the road, and I'll also have it listed over on my website. So anyway, until the next video, we'll see you then. Bye.